Hello, welcome to my electronic lab series. I'm still talking about lab current source, and now I am talking about design considerations. Here is complete schematic. I already have explained output stage, where we have reference voltage and we adjust current, and feedback resistor determines output current on our output terminals. Reference voltage basically we get with a zener diode, but you see some circuit here. I'll explain why. So to have a reference voltage we need one zener diode. This is, we need one zener. Okay, I use 3.6 volt, pretty low voltage, because I have potentiometer of 100 ohm. Since I want 0.8 volt on 100 ohm, so we can calculate that 8 milliampere is flowing through my potentiometer here. 8 milliampere flowing. But also we need some current through zener diode, let's say 2 milliamp. So in total we need at least 10 milliampere here. At least. Okay. The problem is that the supply is some adapter between 5 and 24 volts, so it must operate for 5 volt and for 25. If we connect 5 volt, then the voltage difference is 1.4 volt between supply voltage and zener voltage. If we connect 24 volt supply, then voltage difference on this resistor is 20 volt. So we must ensure at least 10 milliampere here, so we have enough current for our potentiometer and for our zener diode. So we have calculated that our resistor is 140 ohm. Sorry, that is kilo ohm. Yes, 0.14 kilo ohm, or it's 140 ohm. And when we connect 24 volt, then the current flowing here is 145 milliampere. So this circuit principally works, but the problem is too high current in case when we use higher supply voltage. Only 8 milliampere flows here through this resistor, so the rest 137 milliampere will flow through our zener diode, and this is too much. And that is why I have used operational amplifier to design reference voltage. How does this work? Very simple. A reference voltage is still obtained by zener diode, but the resistor is higher. This leads to pretty low current if I use 5 volt, but still enough for zener to work. The principle of operation of operational amplifier says there is no current flow to the input terminals, so all current will flow through zener diode. And since operational amplifier tries to keep the zero voltage between input terminals, reference voltage we will have here on this point. 8 milliamperes needed for our transformer, for our potentiometer, will flow through operational amplifier. So regardless of voltage, we do not need to ensure with this resistor to bias zener diode. we do not need to ensure this current of 8 milliamperes that will flow here. So, although the current for our zener diode will change, the operational amplifier will give the current to our reference potentiometer for regulating output current. And that looks like this. That is our complete circuit. Zener diode, a resistor, that is operational amplifier 1. It is one chip because the used amplifier is LM3424. Here is referent voltage output. Here is potentiometer for regulation, here, and here is output, integrated circuit that on this feedback keeps the same voltage as on reference input, and that's why the output current is determined by the value of these resistors. And this is switch to change current ranges. So this is complete schematic of our lab current source. Thank you for watching. Stay tuned. Bye until next video.